Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Amin. Okay, good morning everyone. Okay, today I want to actually discuss frame with side sway. I actually don't want to focus on the explanation, but I want to focus on the example. Okay, means how to solve MDM frame with side sway problem. Okay. If you have any question, you can ask in the live chat in the YouTube, or you can also write the question in Teams chat. Okay, in Teams chat. Okay, can you comment? Okay, can you listen to me? Can you listen? Boleh dengar suara saya tak? Okay, can you listen to my voice? Okay. So in the screen right now, so this is actually frame with side sway. This is actually the side sway frame. This frame is tend to sway to right direction. Okay, right direction based on the given 300, which actually push the frame to the right side. Okay, and actually due to the geometry as well, this frame will move to the right side. Okay, to the right side by looking at the geometry as well. So this is actually frame with side sway. So we have to analyze this frame by using two table. We apply principle of superposition. So we have to have two table. So in the first table, we have to analyze non-side sway frame. Because we have to because FEM in this main diagram has actually FEM due to loading and due to delta. So we have to actually separate between loading as well as delta side sway. So in order to remove delta from the frame, so we have to put an imaginary support. So this is table number 1, diagram for table number 1. What we need to do is we have to put an imaginary support at C, and with this support, so R will be exist the restraining force. So this is now called as properly restrained frame, and we will only calculate FEM for this diagram due to external loading. Okay, so this is for the first table. So we have two table. Table number 1, properly restrained frame. Okay, where we only calculate FEM due to external loading. And we will have table number 2. And table number 2 is actually side sway frame. Okay, side sway frame. This is for table number 2. The diagram for table number 2. So this is due to R prime because we analyze it indirectly. We don't analyze the frame subjected to R. Okay, because we do not know the delta value. So what we should do is we have to have another frame which is proportional with the one that we should have. Okay, that we get from principle of superposition. So this is actually frame to be analyzed for table number 2. So in this in this frame we only have side sway. We don't have FEM due to loading. Okay, due to loading we only have side sway. So this frame is subjected to R prime. This frame is subjected to R prime, so this will be analyzed in table number 2. Okay, so we go back to table number 1. So we will analyze fixed end moment first. Okay, we will start with the first thing that we need to do is we should know that in summary the procedure to analyze frame using MDM is we have 4 steps. Okay, 4 steps. So step number 1, okay, of course we need to know how to calculate K as well as DF. So this DF will be used in both table 1 and table 2. Then we have step number 2. Step number 2 will be the first table. So this is non-sway frame. Non-sway frame. This is non-sway frame. Okay, in non-sway frame, okay, we have 3 steps under non-sway frame analysis. Okay, number one is FEM. This is due to loading. Number 2, after we have calculated FEM, of course FEM is the first member and moment in the table, so we will use this FEM to distribute moment, and the total moment from table number 1 is M naught. This is N moment, this is M naught. Okay, we label as M naught. Okay, and from M naught we can actually identify or calculate R. We can calculate R or restraining force using static equilibrium. Okay, this is 4 step. Okay, 3 steps that we need to do in analyzing of non-sway frame using this diagram. So I will move this to Excel so that we can do it using Excel. Actually, because this is the repetition process, so we can actually analyze it using Excel. So I open the Excel first. If you have any question, you can write, okay, either in the live chat or in Teams. Okay. Do you have any questions so far? Okay, so this is the frame. Okay, so straight away I want to actually create the table. So the table start with member. Okay, so we have AB, one member, 2N, BC another member number 2 has 2N, and CD also another member number 3, so 2N. So all are 6N. Okay, because we will establish or we will analyze N moment, member N moment. So each member has 2N, so total member N moment equivalent to 6. Okay, equivalent to 6. So we start with AB, BA, BC, CB, CD, as well as DC. So total member and moment, okay, 6. Okay, so in the table, I will calculate K, okay, directly in the table. So K is in terms of EI. So I put EI because when we establish K, the K that we establish is in terms of EI. Because whenever we want to calculate distribution factor, the EI will be cancelled. Okay, so K for AB. So AB and BA it is actually the same thing. Okay, the same thing, just I write it 2 times. AB, BA. Okay, so it is okay, fix and far and fix. Far and fix for member AB. Far n is referring to A, so it is far n fixed. So we use 4 EI over L. EI is EI only. So it is 4 EI outside over 8. 8 is the length. Okay, it is 0.5. So BA is also the same. Okay, 0.5. Okay, BC, okay, B and C are rigid join. Okay, so rigid join, we apply the same 4 EI over L. 4 EI over L, so it is 4 divided by 6. 4 divided by 6, so we get the same. Okay, so these two value. Okay, I use up to 3 decimal places. Okay, CD, DC. So it is okay, N, far N. D is actually the far N. Okay, far N is pin. Far N pin, we use 3 EI over L. 3 EI over L, and okay, it is 2 EI. Okay, it is 2 EI. So 3 times 2. It is 3 times 2 divided by 7. Okay, so please the rest check whether I am calculating the right value, the right answer. Okay, 3 decimal places. Okay, so for DF, okay, DF distribution factor, we get DF from member stiffness divided by joint stiffness. Member stiffness divided by joint stiffness, and for fixed distribution factor is equal to 0. And for pin, distribution factor is equivalent to 1. Okay, so to calculate DF for BA, it is 0.5. Okay, divide by total BA plus BC. Okay, located at joint B. K for joint. So BA plus BC. Okay, so So we get 0.429. And then for BC, it is 1 minus 0.429. Okay, so we get 0.571. We get 0.571. So we move to CB, CD. So for the FCB, we repeat the same process. It is CB divided by CB plus CD. Okay, CB plus CD. Okay, it is 4375. Okay, 4375. I use 3 decimal places. It is 1 minus 0.438. So we get 0.563. So settle, okay, for distribution factor. So we move to FEM. So this is FEM for the first table. So for the first table, we only have FEM whenever member has loaded. Okay, it is just like we distribute the UDL equivalently, like what we have done in stiffness matrix method. So AB has no value, CD also has no value. We only get FEM value for BC. It is W 70 kN per meter along 6 meter length. Okay, and it is behavior. The moment will counter back the band beam to its original position, which is straight position. So that is one value is negative, one value is positive. Okay, it is negative. W is 70. L is 6 meter times 6 WL square divided by 12. So it is 210, negative and positive. Okay, we get 210. 210. Okay, so remember that FEM is the first member and moment in the table, and then we will start with the first distribution. And remember, at distribution level, what we do is actually we distribute joint moment. We distribute joint moment, not member and moment. And joint moment is always opposite with member and moment. So like I always repeat in my previous video. Okay, the first one is distribution. Okay, the first one is distribution. So we start with BA, since AB the factor is 0 and there's no moment value. So the total moment for B, joint moment for B, so it is BA plus BC, but in opposite condition. So that is why I always put negative to represent the opposite condition of moment. Okay, of moment. So we get total from FEM. Okay, because FEM is opposite with joint moment, so I put negative outside. So I times with distribution factor 0.429. So I get 90. Okay, I get 90 here. So we repeat the same process. It is like this. Okay, it is 0. Okay, and negative 210. I have put negative outside. So time with distribution factor. Okay, so we get 120. So total 1, 2, 3, 4. The one that I highlighted. Okay, 1, 2, 3, 4 ni. Okay, total must be 0. Okay, so we distribute the joint moment at C. So we repeat the process. It is negative to represent the opposite condition of joint moment. So it is FEMCB plus CD. times with distribution factor. Distribution factor. Okay, enter. We get 91, negative 91.875. So we get the remaining. Because it is just different between 210 and negative 91.875. Plus times 0.563. 0.563. So I put, okay, dollar sign ni is to lock the column. Okay, if at DC, okay, if DC has value, then we need to time with 1. Okay, the join moment has to time with 1, but now there's no FEM value for join D, so like this lah. Okay, so okay, next is carry over. Carry over, actually we only use the factor. We don't calculate, okay, the factor. We just use the factor. So we apply the factor. The factor is 0.5, 0.5 and 0 for pin, 0.5 for fixed end, and internal member, rigid joint as well. And then DC tu at D, because D is pin, so there's no value because the factor is 0. Okay, so we carry the value to opposite joint, means that the value from BA we need to carry to AB. So we time with the factor 0.5, it is 90 divided by 2. Okay, 90 divided by 2. And the value for BC we need to carry to CB. B to C, B to A. So 120 we have to time with factor. So it is 120 times 0.5. Okay, like this. We get 120 divided by 260. Okay, and then C to B. C to B we have negative 91, negative 91.875. This value we need to time with 0.5. Okay, we get 45, negative 45.9375. 9375. And okay, C to D is actually negative 118.125 times carry over factor, and the factor is 0. So when the factor is 0, so we get 0. But if DC is fixed, so we need to carry the value. Okay, so this is the carry over. Then we need to repeat the process. For the second distribution. The second distribution, I will copy whatever has here. Okay. Okay, so this is the answer. So we can check this 4 value. This 4 value, is it total is 0? Negative 45.938, 19.6875 and 26.25 ni. We must check, is it equivalent to 0? Okay, so same goes to this 60 minus 26.25 minus 33.75. Is it 0? Okay. Then if get 0, then we should continue to carry over. So I copy this carry over. Okay, copy. Okay, actually boleh copy the whole also. Okay, now dah carry over, right? So this is carry over. Okay, distribution, carry over. Copy the whole. Okay, we repeat the cycle, we repeat the process until the last distribution. The last distribution reaches 0.0. Okay, the last distribution reaches 0.0. Okay, maybe one more time. Okay, so distribution carry over, distribution carry over, distribution carry over, distribution. Okay, so last carry over ni I will clear, because you must remember that we should stop at distribution, not at carry over. Okay, yang ni 3 decimal places. Okay, do you have any question? Do you have any questions? So you should understand the process. I have explained the process in my first FEM with Satsway video. Okay, tengok balik that video where I have explained the moment that we distribute is actually the join moment, not member M moment, and it is opposite with member M moment. So kita total ya. So we will now total the moment. Okay, total moment start from FEM. Start from the first moment. The first moment in the table start from FEM. So total. Okay, now dah dapat Okay, ni dia. Allah, sini. So this is M not. Okay, this is N moment from table number 1. I label it as M not. Okay, M not. So this is the value. Okay, so from this, okay, the last value is 0. Okay, so we get here. Nampak tak kat sini kan? Total ni, okay, equivalent to 0 because rigid join MB is equivalent to 0. MC also equivalent to 0. Okay, MA yang ni 58.447 is actually MAB or equal as MA, and there's no moment at D because D is spin. Okay, D is spin. So this is M. This is MB, which is equal to 0. Okay, and MC, which is equal to 0. MB and MC is equal to 0. So we bring this value, okay, to continue to calculate R value. To continue to calculate R value. Okay, do you have any questions so far? Do you have any question? So I want to copy this answer first. Is it okay? Boleh komen dekat live chat, boleh komen. So now kita nak pindah balik ke OneNote. So saya nak copy this value. Okay, I copy the whole table lah. So mana dia? So dia kan kalau non-short wave frame ni, dia beam ke dia frame ke dia sama je. Okay, the difference is only at table number 2. So yang ni part ni kalau kita analyze beam pun sama je proses dia kan. Cuma kalau beam tu kalau without settlement, this is the process. Kalau with settlement, we have to add additional FEM which is come from settlement, because settlement is always we know the settlement. Settlement is given in the question, so we can have one table to analyze beam with settlement. Okay, we can do separately, we can do together in one table. So but we cannot do that for frame. Frame with side sway, we must have two table. Okay, so I want to copy this. So move back to this. Okay. So now nampak kan? Okay, this is all the moment M naught. Okay, this is M naught means that the end moment, member end moment for table number 1 non-side sway frame. Okay, non-side sway frame. Okay, so we refer to the first diagram ni, the diagram for table number 1. So in order to calculate R value, what we need to do is we have to, number 1, we have to draw the free body diagram. Because in order to calculate R value, we have to write equation for R. Equation for R. So equation for R is called as shear equation. We get from from this diagram. So what we need to do is we have to put all the macam ni lah. Okay, dekat A tu, it is fixed end. So, dekat fixed end, normally kalau fixed support, apa kita buat? Kita akan letak the free body diagram. Free body diagram untuk, for fixed end, we have yang ni. 3 unknown reaction. So, this is the principle, right? That you have actually learn masa mula-mula sekali dulu. Masa slope, bukan slope. Apa nama tu? Solid mechanic. When we have fixed support, we have 3 unknown reaction. So we put like this, 3 unknown reaction. Direction dekat AY tu you may put in the other way around, doesn't matter. Okay, it is we just need to put the value and we will calculate based on what we put. Okay, so we have here at A 3 unknown reaction, and then at D we have dy and dx. Okay, direction tu ikut suka nak letak arah mana. Direction dx dengan ax tu. Okay, so I have put like this. So this is my ax. This is ax. This is dx. Okay, ax and dx. So moment at A ni. This is moment at A. This is also equal to MAC. Okay, and we have AY and dy. And AY and dy ni actually tak masuk pun dalam calculation to determine R value. Okay, to determine R value. Yang akan masuk nanti kejap kita tengok. Okay, shear equation. Okay, it is called as shear equation. Shear for column. Okay, shear for column. Because when we talk about frame, because side sway tu is horizontal displacement. So, shear referring to column lah. Okay, the vertical member. So we will actually write the shear equation for this frame. Shear equation for this frame. And by looking at this, we can write the shear equation as, okay, shear equation tu, apa maksud shear equation? Shear equation ni yang ni. Total Fx equal to 0. Shear equation. Total Fx is equal to 0. So, it will relate with all horizontal forces, including all horizontal reaction at support. Okay, so we can write the equation. So, it is, okay, by looking at this, we get 300 minus R plus AX minus DX equal to 0. Okay, shear equation. So, it is, so ni, Fx is equal to 0. It is 300 minus R plus AX minus DX. So plus AX dengan minus DX ni depend on the direction that we put in the diagram. So depending on how on which direction that we put. Okay, so 300 minus R plus AX minus DX equal to 0. So this is okay, the equation to calculate R. So R is actually 300 plus AX minus DX. So this is actually equation to calculate R value. So now we have two unknown. We have AX, we have DX. So to calculate AX and DX, we have to do what we call is as column analysis. It is column analysis. So we have to analyze column AB and column CD separately. Column AB and column CD separately. So in order to analyze column AB, so we have to do column analysis. Column analysis. Okay, we have column AB. Cantik kena pakai ruler juga. Okay, sekejap Okay, we have column AB. Okay, column AB. Column AB, this is column AB. So ini A. This is B. Okay, column AB. AB 8 meter. Okay, AB we have tadi ada AX kat sini. Okay, AX. Okay, at A and at B we have internal moment. Internal moment we get from table. Internal moment we get from table. Okay, it is 58.447 and 116.97. Ambil 2 decimal places dah lah. Okay, 58.45 and 116.97. So both are positive. So positive. Kat sini positif, sini pun positif. 116. Yang ni tadi 58.45 ke? And 116.97. 116.97. Okay, so this is for column AB. This is for column AB. So what we should do is we will take moment at B. Take moment at B. Take moment at B. Okay, when we take moment at B, we can get AX. So it is just like static equilibrium. It is just like we analyze simply supported beam. Okay, so by taking moment at B, AX tak masuk, AY tak masuk dalam calculation. Okay, by taking moment at B, 300 also tak masuk dalam calculation. Okay, that is why I only put whatever needed. Okay, whatever needed. So we have 58.45 plus 116.97. Okay, AX tu negative AX times 8, and this is equal to 0. Okay, this is equal to 0. So then solve this. By solving this we get AX. By solving this we get AX. Okay, by solving this we get AX. Dapat apa AX ni? Tengok sini kejap. Okay. Okay, it is 58.4 58.45. Okay, plus 116.97. Okay, total. Okay, divide by 8. Okay, it is 21.93. 21.93 kilo Newton. Okay, kilo Newton. Okay, can you do for for CD, for for DX? Okay, can you do for CD by taking moment at C? Please find dx value. Okay, so the moment at C is negative 161.96, negative 161.96. Okay, and this is the diagram. Okay, member CD, so there is moment at C, no moment at D because D is spin. So it is 7 meter. So what is the value for dx? Can you please calculate for me the value for dx? Who want to try? The value for dx. Actually the same thing. We should do the same. It is for column CD. Column CD. Siapa nak try? Calculate. One six one point nine six. 161.96 is negative. 161.96. This is 7 meter. So dx belah sini. This is dx. So taking moment at C is equal to 0. Taking moment at C is equal to 0. So we have negative 161.96 plus dx times 7 equal to 0. Okay, of course R is not included because okay, we take moment at C. Sama juga dengan dy. Dy is also not included. Okay, dy is also not included because okay, and kita consider is all which is perpendicular. Okay, dapat apa ni dx? Dx we get 161.96 divided by 7. It is 161.96 divided by 7. So we get 23.13714. 23.14. So this is kilonewton. So R is equal to 300 plus AX minus DX. So it is 300 plus tadi dapat 21.93. 21.93 minus 23.14. So we get 300 equal to 300 plus 21.93 minus 23.14. So we get 298.79. 298.79 kilonewton. Kilonewton. Okay, settle part side sway, non-side sway frame. Okay, we have done okay until step step 2C. Okay, we have done until step 2C. Okay, move to the next step, step 3. Okay, step 3 is side sway frame. Okay, where FEM is based on assumption. FEM delta is based on assumption. Based on assumption. And then after that, B and C, we repeat the same thing. B and C, we repeat the same thing. Different is only due to FEM. B and C, of course we will get M prime and R prime, but the process is same. So BC ni dengan BC yang bawah ni, okay, we actually repeat the same process. Dua-dua ni sama. Okay, repeat the same. Okay, repeat the same process. So different is only dekat A. A only the difference. M prime tu dah masuk dalam table FEM, so proses tu repeat the same. Kalau you dah buat dalam Excel tadi, you just ganti nilai FEM, so automatically dah dapat terus jawapan. Okay, that's why when I set up the table, so I have actually put all the formula. Lepas tu ada nampak dollar sign semua sebab saya nak lock the formula, lock the column. So that when I change the FEM, so automatically I will get the answer. So dah dapat FEM nanti, for FEM due to delta, which is based on assumption, kita ganti je FEM dalam table tu. So kita akan dapat M prime. Okay, directly M prime. And of course R prime kena do some calculation, tapi dia exactly repeat balik proses yang kita buat untuk dapat R ni. Okay, dia akan exactly repeat balik the R process. Okay, so kita nak fokus kat sini. Yang mana yang ada kelas lain boleh move to the next class. Yang lain-lain yang baru masuk boleh yang tak ada kelas boleh continue. Yang lain yang baru nak masuk boleh masuk. Kita akan continue sampai pukul 12. Okay, so kelas pukul 9, pukul 10 kelas pukul 9 saya akan fokus on how to assume FEM to analyze table number 2. Okay, how to assume FEM. So this is only the difference. So frame with side sway, kat sini je difference. Sama juga frame with side sway for 1 incline column, for 2 incline column, kat sini juga difference. Okay, yang lain-lain tu semua the basic principle, the basic thing only. Because once we have this, so we can repeat the same process and we get R prime. Dah dapat R prime, dah dapatlah semua unknown yang boleh fulfill principle of superposition. And then kita akan dapatlah the final M moment. Okay, so yang group yang sekarang pukul 9.10, yang tak ada kelas boleh stay, yang ada kelas boleh move to the next class. So kita akan continue balik pukul 10. So take 5. Okay, Assalamualaikum warahmatullahi wabarakatuh. So we move to the second part. So in the first part, actually, I have discussed discuss on the non-sway frame analysis. Non-sway frame analysis. Actually, non-sway frame analysis is quite straightforward, yeah. Okay, where we have to consider FEM due to loading. So when we consider FEM due to loading, we just need to substitute the value into the formula. So the FEM that we have calculated, we put into the table. Okay, into the table, because FEM is the first member and moment in the table, and then we will start do distribution process. And remember that the moment that we distribute is not the member and moment, but the join moment, and join moment is always opposite with member and moment. So when we after we put the FEM to the table, we do distribution process, we carry over the value, we repeat the process again and again until the moment in the table reaches 0.0 something, 0.0. When we reach 0.0, then we may stop. Okay, we can continue repeat the process, doesn't matter, but we can actually stop after we get reach 0.0 something. Okay, and remember to stop the process at distribution, not carry over. So the last one must be distribution. Okay, the last one must be distribution. So after we stop distribution, so we have to sum the total moment in the table, starts with FEM. We start with FEM, we sum all the moment until the last distribution. Until the last distribution, then after that we will use the moment in the table in order to calculate R value, the restraining force. Okay, so actually for step number 2 and step number 3, step number 3 will be focusing on table number 2. Table number 2 is actually side sway frame, and the difference between step number 2 and step number 3 is only at FEM calculation. FEM calculation, because that is only the FEM due to side sway, or FEM due to delta, because this is based on assumption. This is based on assumption that and we do this indirectly. We have to analyze the frame which is proportional with the actual frame which we get from principle of superposition. So this is actually the frame. So let me show you the frame. Okay, this is the frame for table number 2. Frame for table number 2. This is the frame which is subjected only, okay, due to R prime. Okay, it is subjected to R prime only. There's no FEM due to loading. There's no FEM due to loading. So this frame has only got the effect from side sway, the delta. And we actually don't analyze FEM due to R. We analyze FEM due to R prime, because in this table, in this step, we will assume FEM. So this is the frame that we need to analyze. For all question. So whatever question that we get, so the difference is only due to the geometry, the column length, okay, the beam length. R will be there, okay, and this R we put at C because the frame is tend to sway to right direction. Okay, start from the original. Of course, we start from original diagram. If the frame is tend to sway to left direction, then we should put R in at B, not at C. Okay, so this is table number 2. We focus on this table right now. We will analyze M prime in M prime. Okay, in order to determine M, we have to have this frame. Okay, so this frame we have due to R we get delta prime. Ini. Okay. So due to R prime, we will have delta prime. Due to R prime, we will have delta prime. Okay, so this delta, okay, delta at B and at C, we should assume both are same value. Okay, so delta prime. Because we will look at the behavior occur for both column AB and column CD due to delta. Due to delta. Boleh dengar suara saya kan? Okay, so lukis ni maybe tak berapa tepat, tapi the concept is yang dua-dua ni kita must assume dia sama lah. Okay, this is delta, this is also delta. Delta prime and not delta. Because we cannot assume directly. So this is indirect. Okay, saya dah mention about direct indirect di dalam previous video. Okay, we have to make assumption. So when we make assumption, kita tak boleh make assumption for the real diagram. The direct one which we get from principle of superposition. Tapi this is the one that is proportional to to side sway frame in the principle of superposition. Okay, R prime, delta prime, so we will have M prime. So that is why the end moment label for table number 2 we label as M prime, because we get from this R prime, delta prime, M prime. R prime, delta prime, M prime. Okay, so we will assume FEM based on the side sway, based on the column side sway. So beam will always follow column. So we don't get the effect from beam. So the effect of side sway we can get from column. That is why we focus on column only. So we have now AB and CD as column in this frame. So we have to what we do is actually we will assume the FEM for one column. For example, we assume FEM for AB. After that, we will find FEM for CD using geometry of the column. So it is actually based on the ratio. Okay, so the step that I want to show to you based on the given example, okay, in the textbook. Okay, but before that, one thing important is whenever we want to assume FEM due to side sway, what most important is we must understand that FEM is actually the behavior. FEM is behavior. It means that the sign that we put for FEM must represent the right behavior. Okay, so we must refer back to the FEM concept. Okay, FEM concept for delta. Okay, where the angle of rotation must be opposite with FEM. Okay, so all the principle of FEM I have actually discussed in my previous video. Okay, there are about 5 previous video you can watch back. Okay, so I will focus on the first column, member AB. So in member AB, the original position for member AB is vertical, and the new position for AB is B prime. Okay, the new position where A remains at the same position. So the angle, okay, the rotation, okay, start from new position to new position, okay, is measured. So it is clockwise. And FEM will counter back. So for example, like this, when this pen, okay, this column is tend to sway to this direction. Okay, ni original vertical, move to, due to side sway, move to the other position, and moment will counter back. So that is the concept. Okay, original position due to side sway, move to new position, moment will counter back. So that is the behavior of the column. Okay, due to side sway, due to delta. Same goes to the other side. So this is the straight position, the new position. Okay, the original position, which is vertical, and if it is moved to this side, okay, the other side, and FEM will push back to its original position. It is counter back. So move this, rotate this way, okay, moment counter back. Okay, rotate this way, moment counter back. So that is actually what is happening. Okay, so chord rotation, this is the chord rotation. It is positive chord rotation. So the moment must be counter back. So I put in green color, so moment. Okay, so the one that we assume is not delta. The one that we assume is FEM. So we suggest you to assume 100 value. The moment is 100 based on the suggestion that have been made by the textbook, 100. But what this 100, okay, this 100, we have to check whether it is negative 100 or positive 100. Negative 100 or positive 100 will depend on the behavior. Okay, to counter back. Okay, so based on this diagram, because the angle is clockwise, so FEM is opposite. The angle is clockwise, FEM is opposite. So FEM is counterclockwise, so it is negative 100. So we have to assume FEM equal to negative 100. Okay, so that moment will counter back. Okay, the behavior of the column after side sway to its original position. So the assumption is like this. So it is FEM because it is fixed, and this is fixed. So we have AB as well as BA. FEM AB, FEM BA. This is negative 100. Negative 100. This is assumption. Okay, this is FEM AB, FEM BA, because the condition of the okay, D is fixed, A is fixed, B is rigid joint. Okay, so and when we apply FEM, of course we can assume both ends are fixed. Okay, kilonewton meter for the moment unit, kilonewton meter, it is negative 100. We cannot, when this is the case, we cannot put 100 as FEM. Because if we put FEM as 100, what happened to the column? The column is now like this. When we apply negative 100, we apply moment like this. So we push back the beam to straight position. This is representing negative 100. Okay, negative 100. But if we put the wrong sign for FEM, for example, the column is like this after side sway, and we apply 100, means positive 100. Positive 100 means this. So when we apply moment, okay, clockwise, what happened? Positive 100, what happened? We actually push this beam. We actually push this point. We push. Okay, so dia akan collapse. Okay, that is the behavior. We want the column to counter back. We want the moment to counter back the column position. The column must be remain straight. The column must be remain vertical. Because if we apply positive 100, it means that we push down. Okay, not push up the column. Okay, so that is why that is the importance of understanding the FEM. The FEM for delta is not same with FEM due to loading. Okay, so it is negative 100 because of the behavior, and due to this. Okay, okay, Assalamualaikum. Sorry. Actually, I am working from home today. Okay, about FEM due to set square based on assumption. So we have to make assumption based on the behavior of the column. Based on the behavior of the column, that is why it is negative 100 whenever the frame is tend to sway to right direction. If left direction, then it will be opposite. If the frame is tend to sway to left direction, then the FEM must be positive. Okay, because of the behavior. So having this, we have to apply the formula to calculate FEM. Formula to calculate FEM due to delta is 6EI delta prime over length is 8. And EI is EI, not 2EI. 2EI is for column CD. Okay, 6EI delta prime over 8 square, L is 8, and this is equal to negative 100. Negative 100. Okay, I want to put positive here to represent the angle. To represent the angle, the chord rotation. So having this, we okay, simplify this as EI delta prime, and it is negative 100 times 8 square divide by 6. Okay, EI delta prime is equal to negative 100 times 8 square divide by 6. So this is EI delta prime. And then this EI delta prime will be substituted into FEMCD. FEMCD means that we have to now consider the formula to calculate FEM for CD. So FEM for CD, okay, the difference between FEM for both end fixed due to settlement or due to side sway, kalau dua-dua end to fix, kita akan pakai 6EI delta. Tapi in this case, D is spin, so there's no moment. So we will only calculate FEM due to end rigid joint C, and the formula will be 3EI. Okay, not 6EI. 6EI means both end has moment. Both end has moment if we use 6. Okay, for this example, for this question, since D is spin, so we only got moment. Okay, we only got moment for CD. Okay, for CD, we only got moment for CD. So we will use 3EI, not 6EI. And actually, we can also use 6EI, but we have to do some modification in the table. Okay, so FEMCD. So the formula is okay, look at member CD. It rotate clockwise. It rotate the same. Okay, rotate the same, so it is clockwise rotation. So the angle is positive. This is for the angle. And we use 3EI. Okay, for member CD, it is 2EI. So 3 times 2. 3 times 2 EI delta prime over length is 7. Length is 7 square. So this is the formula. 6. It is 3EI, but for the diagram, we find that it is 2EI. This is 2EI. Okay, 2EI. So it is 3 times 2. 3 times 2 EI delta prime divided by L squared. So we continue to substitute EI delta prime into the FEMCD. So we will get So we will get 3 times 2, 6. 6 over 7 square. Okay, times with negative 100 times 8 square divided by 6. Then cancel this. And then we will get negative. Of course, it will be negative because AB and CD can move in same direction. Okay, same direction, but not happen for the settlement. Settlement will be one negative, one positive. Okay, so it is 8 square. 8 kali 8 apa? 64. 64 6400 divide by 7 ke 7 49. So we get 130. 130. So this is actually the ratio. 130.61. It is negative 130.61. 130.61. Okay, 130.61. This is kilonewton meter. Kilonewton meter. So this value we use in the table number 2. Table number 2. So I move back to Excel. Okay, I move back to Excel. So this is actually the first table. And for those who just joined this session at 10, so please rewatch from the beginning, because I have explained how I made this table. Okay, how I made this table. So I just want to change the value in the FEM column. Okay, in the FEM column. Okay, in the FEM column. Okay, now we have FEM for AB and BA is negative 100 for both. Negative 100. And BC and CB, beam. Okay, beam. There's no FEM for this type of frame, so it is 0. Okay, and then we get FEM for CD just now. FEM CD just now, it is 130.61. 130.61. 130.61 negative. It is negative 130.61. 130.61. Okay. So actually we can recheck whether it calculate the right answer. Okay, 3 decimal places. Mana dia? Okay, so we can check whether we get the right answer. So it is negative 100. Kat sini boleh check ya. Whether we get the right answer. This 4 value. This 4 value. Do we get 0? If we get 0, then means that the calculation is correct. So it is 100 minus 44 or 42 minus 57 tu. Is it the right one? 42.5857 plus 57.143. So the right value. So 57.142 plus with the 73.4 468. 468. We get 130.61. So this is correct. Okay, this is correct. So means that this is correct. I just need to change FEM. So automatically I get the final. Okay. And this is M prime. This is not M naught anymore. This is table number 2. So this is M prime. This is M prime. So M prime for table number 2. It is negative 83.8653 and then negative 67 and positive 67. Positive 67. So three decimal places. Okay, I will copy this and put in the OneNote. Kejap. Okay, this is the second table. So this is the second table. Okay, so once we have this table, so we should repeat the process in order to analyze or calculate R prime value. So we will focus on the diagram. Okay, this is the diagram. So in this diagram, okay, as what we have done previously in the first diagram for table number 1. Okay, for table number 1. Okay, I will put the free body diagram, the reaction at the support, at support A and at support D. So we have 1, 2, 3 at fixed support and 1, 2 at pin support. Okay, so this one is AY prime. This is AX prime. This is DY prime. This is DX prime. And this is M prime. AB. Okay, M prime. So we have to write shear equation. We have to write shear equation to relate all horizontal forces, including a horizontal reaction, okay, in this diagram. So we have horizontal forces here is R, AX prime, R prime, AX prime, and DX prime. So we have to make a relationship, okay, using total Fx equal to 0. So the same process that we have done previously whenever we calculate R value. Okay, so this time we will focus on R prime, table number 2, R prime. So we have to make a relationship, okay, using the same shear equation, which is Fx, total Fx is equal to 0. So total Fx is equal to 0. It is R plus Ax, R prime plus Ax prime minus Dx prime. Okay, it is R prime plus Ax prime minus Dx prime. So we use this as the diagram, okay, to be referred. So we will write equation based on whatever we have in this diagram. Okay, so for table number 2, for diagram number 2, okay, so we have the equation. For the equation, it is f total fx is equal to 0 if it is in right direction. And r, we have r prime. We have r prime plus ax prime. Ax prime minus dx prime. And this is equal to 0. This is equal to 0. Okay, so r prime is equal to dx prime minus ax prime. So having this, okay, we should write the equation based on the column analysis. We call it as column analysis. So we have to analyze column AB and we have to analyze column CD. Column AB, so we have column AB. For column AB, we have 8 meter. AX in this direction, this is AX prime. Okay, and the moment we take from table, moment. Okay, the moment we take from table. So the moment here is negative and negative. Negative 83.65 and negative 67.36. Negative 83.65 and negative 67.36. So we apply negative moment. Negative here, negative here. And the value is 83.65. This is 83.65 and 67.36. 67.3. Then we will get AX. Okay, we will do the same for column CD. For column CD, okay, it is 7 meter. We have dx like this. Okay, dx prime like this. And the moment is negative 69. This is 69.4. Negative 69.4. Okay, this is 69.4. So we will get dx prime, okay, whenever we take moment at C. Okay, so we have to calculate ax and dx. Calculate ax and dx, and then we need to substitute into this. Substitute into r prime, which is equal to dx prime minus ax prime. Then we will get r prime. So after having all this, so in the principle of superposition and moment, okay, the final or the total end moment is equal to m naught plus r divided by r prime, okay, kali dengan m prime. So using this equation, after we get r prime value, we have actually calculated r value, okay, and then r prime value. So use the column analysis, okay, to calculate ax prime, dx prime, substitute into this equation. So we get r prime. So then we can get r divided by r prime. R divided by r prime is actually base r divided by r prime times m prime is actually representing m. Okay, this is actually representing m. We do this based on interpolation. Because the idea is like this. When we have frame, okay, subjected to okay, side sway. Okay, maybe like this. Okay, so this frame has side sway plus deflection. Side sway plus deflection. So in original frame, we have FEM due to, which is W here, plus delta also. Between W and delta, okay, we have different formula to calculate FEM. And we have to separate between W and delta, because we have to calculate FEM W with given value, and delta is unknown. That is the idea why we have to have two table in frame. Okay, we have to separate between these two. So whenever we separate this, we have to separate using the principle of superposition. The principle of superposition, when we okay, when we apply, we have like this. We have like this. It is due to W. This is due to delta. Okay, we separate between W. We separate between W and delta. So one with W, another one with delta. So how to remove W? By putting an imaginary support at C. So that is why kat sini ada R. And dekat sini lawan dia R. Okay, so if we have A, B and C, A, B and C, so B will be the first table. So ini yang kita buat tadi tu, dalam sejam pertama tadi pukul 9 sampai 10 tadi kita buat yang ni. Okay, table number 1. Table number 1. Table number 2 bukan yang ni. Table number 2 bukan yang ni. Okay, table number 2 bukan diagram C. Because diagram C, delta. Delta ni kita tak boleh assume. FEM due to delta for diagram C pun kita tak boleh assume. Because this is the real one. This is direct one. We cannot assume. So what we assume is the one which is proportional with C. The one which is proportional with C. So yang kita assume tu another diagram. Diagram D. Which is proportional. So that's why yang satu lagi tu yang kita buat for table number 2. Table number 2 tu is, it is actually same thing. Tapi semua kat sini R prime. Sini R prime. Sini delta prime. Delta prime. Dekat dalam ni, ini delta. Delta. So R, delta, M kat sini. So sini M. Sini M. Okay, sini M. Okay, but the proportional one, okay, this is M prime. So inilah dia table 2. This is table 2. Table 2. Yang ni bukan. Yang ni bukan table 2. So it is proportional, okay, to C. So let's say this is D. So yang kita analyze tadi, table 1 is diagram B, table 2 is diagram C. Okay, why we need to have R divide R prime to, how do we get that? Okay, we have to do interpolation between C and D. Between C and D, because dalam ni actually sampai habis solution, we don't need to have or to show to calculate delta value. So we don't need the delta value. Tak tahu sampai habis, doesn't matter the delta value. Because what most important is kita tengok between these two diagram. So we have R that we get from table 1. So R that we get from table 1, guna dia dekat diagram C. The R in under step 2C, okay, R yang kita buat dekat step 2 kan, 2A kita buat FEM due to loading, and then M0 and moment. Lepas tu kita cari R value. So R value yang kita cari dekat that step, actually we use Dekat C ni, bukan dekat B. Okay, so R yang kita cari dekat step 2C guna DC. Guna DC. Okay, so dekat C ni, we should get M. So M ni yang kita punya problem. Okay, we cannot calculate M. We cannot calculate N moment due to side sway because we do not know the delta value. Okay, but we have R that we get from diagram B. Okay, and in diagram D, we can calculate R prime and we have M prime from the table. So when we compare these two diagram, we can write relationship, okay, using interpolation. It is just like saya mention juga dalam my previous video, tak ingat video nombor berapa, I mentioned about this. Okay, the interpolation concept that everyone learn in school. Okay, when we have R and M in one diagram, and we have R prime and M prime in another diagram, so between these four, okay, R value, we know the value. M prime, of course, we know the value. R prime, we know the value. So what is unknown? M is the unknown. And by looking back to the principle of superposition, okay, so this is M prime. Yang table number 1 tu, that's why I don't put M. I put M prime. M naught. I don't put M. So that we will not confuse. So this is M naught. Okay, the label for non-side sway frame, table number 1. So, based on the principle of superposition, we have M total, which is equal to M naught plus M. Okay, equation dia sampai sini. Okay, equation M total is equal to M naught plus M. Okay, M naught plus M. So, do we know M directly? No, we do not know M directly. Do we know M indirectly? Yes, indirectly we know because we have the relationship, okay, that we get from diagram C and diagram D, okay, which is okay, M prime equal to R, M dengan R, mana-mana pun tak apa actually. Okay, M over R, M prime over R prime. And then we want M. So we group R together, R and R prime, time with M prime. So this one we substitute into the equation, the principle of superposition. So that is why here we get M naught plus R divided by R prime times M prime. So in summary, so this is come from table number 1. This is come from table number 2. Okay, and R divided by R prime is called as correction factor. Okay, so having all this, we just need to put back into Excel whenever we have R and R prime value. So we will solve for the M total, member and moment in actual frame. Okay, in actual frame, where actual frame has combination of loading as well as side sway. Okay, so do you have any question regarding moment distribution method? So this is for the basic one. This is basic. So if you understand this, means you should be able to solve any frame problem related to this. And for frame with side sway, the process will be the same for all type, except the geometry, the distance will be different. Then you will calculate the value depending on the geometry of the frame. And if you have any question, you can write in the chat box before I move to sekarang pukul 10.55. Okay, at 11 I will move to the other two types of frame. One inclined column, and two inclined column. So for another two diagram, another two frame, I will only focus on side sway frame. On side sway frame analysis, because the non-sway frame will be the same. Okay, non-sway frame will be the same. I will only focus on 3A. I will focus on 3A part, how to assume FEM and how to determine the other FEM for other element, other members. Okay, depending on the first assumption, because it will relate with the ratio. Okay, so in summary, this is number 1, 2, 3. So number 4 is the equation lah. Number 4 is the equation. M final equal to M, or M total doesn't matter. This is R divided by R prime kali dengan M prime. So this is the equation. Okay, so at 11 we will continue to the next. Okay, another two type of frame. Okay, we will take rest for a while. Assalamualaikum warahmatullahi wabarakatuh. So we move to the third session. Okay, for those who new, okay, who just joined this session. So for the first session, the first 1 hour, about 9 to 10. Okay, at 9 to 10, I have actually discussed on frame with side sway, table number 1, where we analyze. I have actually shown how to analyze table number 1, non-side sway frame, until determining the restraining force value. Restraining force actually is determined from the table using the moment at column AB and moment at column CD. Okay, using column analysis. Okay, using column analysis. And then we actually in second part, I have actually moved to table number 2. Table number 2 focus on side sway frame. In side sway frame, we have to analyze, we have to assume FEM due to side sway. And actually the process in the table for end moment for side sway frame as well as restraining force R prime under step number 3B and 3C will be equal actually with 2B and 2C. Okay, and I have summarized the process, okay, which will be based on the principle of superposition. So the one that we analyzed in table number 2 is actually indirectly, where we have analyzed the frame which is proportional to the frame, the direct frame, which we get from principle of superposition. So that will be the process to analyze frame with side sway for all type of frame, side sway frame. Okay, because we do not need to actually know the value of delta. So what we do is actually the assumption based on the diagram. Okay, based on the geometry, geometry of the frame. And actually for the frame, we do not only have one type of frame. Okay, so depend on the side sway. Okay, the side sway means the delta in the frame. Side sway the delta in the previous frame that we have analyzed. The previous frame that we have analyzed, we have the frame like this. Okay, we have the straight column. When we have straight column, okay, when we have straight column like this, even though the column is not constant, means that the length for each column is not constant, we still can assume that the delta is constant. The delta. That is why we can see from the previous example. Okay, the delta is same. Okay, when we have frame like this, okay, when we have frame like this, okay, about the side sway. Side sway means delta. There is delta which is perpendicular to the member. That is the basic of side sway. It means that when frame is tend to sway to right direction. Okay, kejap. Okay, when frame is tend to sway to right direction or left direction. Okay, what we need to understand is we have to find where is the delta. Okay, if the member is vertical like column, when the member is vertical like column, okay, the delta will be perpendicular. That is why we have the horizontal displacement. The side sway is actually the horizontal displacement whenever the column is the vertical column, the vertical one. So actually a frame has also inclined column. Frame has also inclined column like this. We can also have frame like this, which has inclined column. Inclined column, one inclined column or two inclined column. We can also have frame like the second one. Okay, we can also have frame with second one. We can also have frame like this. Okay, so doesn't matter on how the column look like. What most important is we must understand that the column, okay, between the column and the delta, it must be perpendicular. Between the column and the delta, between the column and the delta, beam will only follow. Okay, beam will only follow. We focus on column first. Okay, in the first diagram where we have two vertical column, okay, beam got no effect at all. Okay, because beam will move horizontally. Beam move horizontally. Beam will move horizontally. There's no vertical displacement whenever frame is moved to right direction. Okay, it is just like this. There's no vertical movement because, okay, this is what we have learned previously. Okay, this is what we have learned previously. It is about shear. Okay, principle. Okay, so for beam there's no movement because beam is vertical, beam is horizontal element, and horizontal, perpendicular or shear force. Okay, because there is no delta in beam. The delta is 0. That is why when we analyze frame with side sway BC, there is no value for FEM for BC for the first one. This is the first one. Okay, the one that we analyzed just now. But what happened to the second one? So the concept is we must focus on column, on the column. So find the perpendicular, okay, the delta which is perpendicular to the column, and beam will follow. That is the concept. So if we have this diagram, this is column, frame ABCD subjected to R prime, because I want to focus on side sway frame analysis only, and in side sway frame analysis the frame, okay, is subjected to R prime. Okay, I will focus on step number 3A only. Okay, this is R prime. So what happened to this frame? So what we should do is we have to identify, we have to understand, we have to analyze. Okay, analyze what we have understand previously. Okay, for the side sway, for the delta must be perpendicular to element, and perpendicular to column AB. In this case is this. So we have to find the delta which is perpendicular. So we assume that this is the Okay, the 90 degree. Okay, the 90 degree. So this is actually the 90 degree. So this is like this. Okay, the delta in beam in column AB, the delta in column AB, where is it? It is perpendicular. Yang ni, that is the delta. Okay, the delta. Okay, it is delta 1, which is perpendicular to member AB. Member AB is member number 1. So ni A, ni B. Okay, delta 1. And then look at column number 2, column CD. Column CD, okay, where is the perpendicular? Where is the perpendicular? Perpendicular. Okay, perpendicular. Okay, so perpendicular of member CD is, okay, is shown here. So the delta, which is perpendicular to column CD, is called as delta 3. Delta 3 prime. Delta 3 prime. Okay, so why we label as 1, 2, 1, 3? Because in this case, all delta is not similar like what we have done previously. Okay, whenever we have two column, straight column, so we can assume that the delta occur at B, delta occur at C, okay, will be similar. Okay, have the same distance. But this will not occur in this case. Whenever there is one inclined member, so AB as element number 1 will have delta 1 prime. CD as element number 3 will have delta 3 prime, and delta 1 and delta 3 prime is not similar. Okay, so when we apply, we have to make sure that the delta must perpendicular to the member. And in this case, we have the vertical distance. We have the vertical distance which represent the vertical displacement or deflection for beam BC. Whenever there is a vertical distance between delta 1 and delta 3, so it is belong to the distance is belong to beam BC. So because we need to join these two point B until for B prime and C prime. B prime B, after sideway, move to new position called as B prime. C, after sideway, will move to new C position called as C prime. So we need to join this. Okay, we need to join this. Okay, we need to join this position, this B prime to C prime. And there is the vertical distance. We measure from vertical, so 0 sini. Okay, means that vertical distance from the lowest delta 1 position, which is B prime, until C prime. Okay, because this is B prime and then C prime. We have B prime and C prime. So the distance tu tadi yang dua-dua tegak kolom yang dua-dua vertical tu, Yang ni sebelah ni kan. Because there's no vertical displacement. Okay, BC tu dia follow sideway. Because B and B prime and C prime, dia move horizontally. Okay, when move horizontally, there's no vertical displacement. Because vertical displacement belong to beam. Because beam is a horizontal member. Beam is a horizontal member. So, vertical displacement belong to beam. So, in this case, frame, whenever frame has one inclined column or two inclined column, it will actually produce vertical displacement belong to beam BC. So this distance is actually delta for beam. This is delta 2 prime because beam BC is member or element number 2. Okay, so we combine these three delta 1, delta 2 and delta 3. When we combine these three, so we have actually this distance, okay, as well as B to B prime. So we combine, so we get this. Okay, the incline representing delta 1 prime. Okay, the vertical representing delta 2 prime belong to beam, and the horizontal representing delta 3 belong to column CD. Okay, so we have this delta 1 prime, delta 2 prime, delta 3 prime. So this delta 1, delta 2 and delta 3 prime, okay, we will use this. Okay, we will use this in FEM due to sideway. So the ratio or the calculation to calculate FEM for AB, BC and CD will be based on this. Okay, so then the difficult part is whenever we need to do some process related to maybe trigonometry or angle. We need to find the angle, or we need to find the angle, maybe trigonometry, and then we have to make relationship between delta 1 and delta 2, delta 1 and delta 3 in order to find the right ratio. And actually this triangular is located in this diagram at, this is actually similar to the one that I have drawn just now. Sama lah. So dua-dua inilah dia. Okay, when I enlarge, this is the thing. So we will have 3 FEM. FEM AB, BA. FEM AB, BA. And FEM AB, BA, we use 6EI delta 1 prime. Because it is for member AB, divide by LAB squared. This is B. And then for FEM BC CB, we have 6EI delta 2 prime over L for BC squared. Okay, and we have FEM CD DC, which is equal to 6EI delta 3 LC CD square. So we have delta 1 prime, delta 2 prime, delta 3 prime. Of course, we will assume one FEM. We can choose any member that we want. Okay, for example, if we choose to assume FEM for member ABBA, so we assume this as negative 100. Okay, we assume as negative 100 kilonewton meter. So if 6EI delta 1 prime over LAB square equivalent to 100 kilonewton meter, so what is the FEM for BC, for member BC, and for member CD related to 100 that we assume? So we must consider, okay, consider the length, the EI, as well as the delta. And in this case, the delta is not constant. Just now, L is not constant. That's why we get different value. If everything constant, then we get the same value. But in this case, EI is not constant because EI is not constant. If EI is constant, then it is constant. Depending on question. L, of course, is not constant. So length of each element will be different. And we have also one thing that we need to consider, and it is not constant. It is delta 1. Delta value. Delta 1 is not equal to delta 2. Delta 1 also is not equal to delta 3. So we have to find the ratio. So the ratio means that we have to identify the angle value. We have to identify the angle value, then only we can have the relationship. For example, if this is 33 degree, we can make relationship between delta 1 and delta 2 and delta 1 to delta 3. Okay, delta 1 and delta 2, we can have sine 33 over equal to delta 2 prime over delta 1 prime. So we want delta 1 we want delta 2 in terms of delta 1 prime. So we get sine 33 is equal to 0.55. Okay, it is 0.545. It is delta 1 prime. Okay, so we have to make relationship like this. Okay, means that we need to identify from the geometry the angle value. Okay, the angle value, then only we can identify the relationship. Once relationship has been determined, then only we can apply into the formula. So that will make different value of FEM. Okay, depending on the ratio of each of the parameter inside. Okay, so for delta 3 and delta 1, we use cos. Okay, we use cos. It is cos 33. Cos 33 equal to delta 2 divided by delta 1. Tadi tu delta, okay, now delta 3. Delta 3 prime, delta 1 prime. Okay, so this is equal to, okay, delta 3 in terms of delta 1, we get cos 33 equal to 0.839 delta 1 prime. Because delta 2 prime and delta 3 prime must be in terms of delta 1 prime. So we can substitute into this because 6EI delta 1 prime over LAB ni, okay, we will get EI delta 1 prime. So in order to substitute into this, we must change delta 2 prime in terms of delta 1 prime. So the same with FEM for CDDC, where we have to have relation between delta 1 and delta 3. So delta 3 must be changed to delta 1 prime. So then is only we can we can substitute the value into the EI delta 1 prime into FEM DC. So actually in frame width side sway analysis, when we have one incline or two incline, this will be the complicated part compared to the other. Okay, compared to the other. So we have to apply actually this is just okay, the one that you have learned previously. This is the mathematical concept that we embed into this solution. Okay, the relationship. The relationship. So once you understand about this, okay, then we can get the value. For example, okay, let's say LAB. Okay, let's say LAB is 7 meter. This is just example, yeah. Okay, LBC is 6 meter. Okay, we just use the previous value. LCD, for example, is 8 meter. Okay, not the same one. This is different. Okay, LAB, LBC, LCD, 7, 6, 8. Okay, the length of each member. Okay, the length of each member. Okay, the delta, let's say, is about 33, that the one that we have just assumed just now. Okay, this is not the right one. The value is just assumption. Okay, of course, the length, okay, the length of each element will contribute to the angle. Okay, this is not tally, this is just example. Okay, the angle. So once we have the angle, then we can determine the relationship. And now how to actually analyze this thing is, okay, so it is like this. Okay, so this is actually 6. Okay, 6. Let's say EI is constant. EI delta 1 prime over tadi 7 7. Okay, 7. This is 7 square. And this is equal to negative 100. Negative 100. Okay, I want to show to you the easiest way to do this. The easiest way to do this. Okay, 6 EI, the second one is equal to, okay, 6 EI, 6 EI, okay, over L tadi 6 square. Okay, delta 1 prime, delta 2 prime, in terms of delta 1 prime is equal to 0.545 delta 1. 0.545 delta 1 times with 0.545 delta 1 prime. Okay, and for okay, the third one, 6 EI, the length is 8 square. Okay, the ratio is 0.839 delta 1. 0.839 delta 1. Okay. So what should we get? Okay, so we get we get 6 EI, 6 EI delta 1 prime equal to negative 100 times 7 square divided by 6. So we get EI delta 1 prime equal to negative 816.667. Okay, 816.667. So we will get this is what we get. So this one we will get when we substitute EI delta 1 prime equal to negative 8. Sekejap, yang ni ada 2. So sini ada 2 Oh no. 2 ni yang previous example. Okay, constant EI. Okay, tak apa. Okay, 6 EI, we assume that EI is all constant, so EI no changes. Okay, the changes is due to length and delta only. So this is how we apply 6 EI delta 1 prime over 7 square is equal to 100, negative 100, representing side sway to right direction. So EI delta 1 prime is equal to negative 816.667. So by substitute the ratio or the relation between delta 2 and delta 1 prime, so we get 6 EI over 6 square. It is 0.545 delta 1 prime. So that we can substitute negative 816.667 into FEM for BC, for member BC. So this is 6 divided by 6 square times 0.545. Okay, we can times directly with 8 times 816.667. 816.667. Okay, so what we get is, okay, 6 divided by 6 square times 0.545 times 816.667. So we get 74. So this is positive 74.18. Okay, kilo Newton meter. Okay, this is kilo Newton meter. Okay, so this is FEM for member BC. So FEM for member CD. Okay, 8 square. 6 divided by 8 square kali dengan 0.839. Kita kali dengan negative 816.667. We get this is negative 64.223. Okay, 24 kilo Newton. Okay, so this is actually the moment that we should use in the table. After considering the delta, okay, the ratio between delta 1, delta 2 and delta 3 prime as well as L. Okay, so be careful with the sign because okay, this is the frame tend to sway to right direction. Okay, okay, this is the angle for AB is positive. The angle for AB is positive. FEM is opposite. FEM is negative. Correct. Okay. For CD like this. Okay, this is CD. So the angle is positive. So FEM is negative. Negative is correct. However, for beam, be careful. For beam, this is beam. Okay, beam, the angle is negative. Okay, the angle is negative. Beam macam ni original position. New position is like this. So, horizontal is the reference lines. So the angle is negative. Okay, the moment we apply should be positive. So the moment we apply should be positive. So we have now the fixed end moment. For frame. Okay, with side sway whenever one column is inclined. One column is inclined. So we do it actually we find the ratio between each member. Okay? So we have another 20 minutes. So I want to do another example. Okay, maybe the right one. Okay, this is just all assumption, right? So we use the right value. Okay, so the right value, but now I want to change to incline for CD. Okay, we can apply the same concept to all cases. So incline is incline is CD, not AB. Okay, so let's say this is this. Okay, yang ni. Okay, so I put A and D fixed. A and D fixed. Okay, A and D fixed. So yang ni 10 meter. Yang ni 6 meter. Okay, 6 meter. Inilah 6 meter. Okay, I put 6 meter here. Okay, so sini 6 meter. Sini 2 meter. So angle ni about 55 degree. Okay, angle about 55 degree. So yang ni A, B, C, D. Okay, and then of course due to side sway there will be R prime. So R prime this direction. This is R prime. Okay, so how the beam deflection, how the delta in this frame look like? Okay, remember that I have said just now that we have to identify the delta which is perpendicular with column. Okay, the delta which is perpendicular with column. Of course, we need to identify first the length for CD. So length for CD we get, this is 2 meter. So we want this height. Okay, we want this height. The angle is 55. Okay, the angle is 55. So we use what? Tangent. Okay, we use tangent 55 equal to H over 2. Okay, tangent 55 times 2. Okay, it is 2.856. 2.86. So length dia is 2.86 meter. Okay, 2.86. 2.86. Kalau rasa kecil sangat, tukar size ni. Tukar ni. So I change this. Okay, tengok kan, kalau tangent 86 dapat apa? Tangent 86 times 2. Okay, tangent 85. Tangent 75. Tangent 75 Okay, tangent 75 lah. So ini 75 degree. Okay, the tangent is 75. So tangent 75, logik sikit. Okay. Tangent 75. Tangent 75 times 2, we get 7. 7.46. 7.46. Okay, 7.46. 7.46 length. CD length. Okay, CD length. Okay, now we want to focus on the delta 1, delta 2, delta 3. Delta 1 will be this. Okay, this is delta 1 perpendicular to column AB. Okay, perpendicular to column CD, this one. Perpendicular. Okay, perpendicular. So this is perpendicular, this is perpendicular. Okay, so there is vertical distance between the lowest position and the highest position. Okay, so we have the distance between B prime and C prime. B prime and C prime, which is the vertical displacement. Okay, so we get this as delta 2 prime. This one is delta 1 prime. This one is delta 3 prime. So when we combine these three, delta 1, delta 2 and delta 3, so what do we get? We combine these three. 1. Okay, this is delta 3. This is delta 1. This is delta 2. Okay, delta 1, delta 2, delta 3. Okay, so for delta 1, it is it is horizontal. So this is delta 1. Okay, this is delta 1. Delta 2, this is delta 2. It is vertical displacement. Vertical displacement because beam is horizontal. So all is prime. And this is delta 3. Delta 3 prime. So of course we need to identify the angle. The angle inside this diagram. So this is actually, when we put into the diagram, this triangular, when we put into the diagram, it representing this. Okay, this one, and this one. Okay, so we need to terbalikkan yang tu lah. So we should have this. Okay, so actually it is the same, delta 2 prime, delta 3 prime, delta 1 prime. Okay, so the value in the diagram, and it is actually, so if we draw it in opposite condition, because dia opposite, dia macam ni, opposite, right? Opposite macam ni. So the angle will be 75 ni belong to mana? 75. Is 75. So remaining is 25. So we have to be able to identify the angle. So the angle will be 25. The angle will be 25. Okay. So this is the angle. This is the angle. So we have to make relationship as we have done just now. Okay, relationship between delta 1 and delta 2 and delta 1 and delta 3. Okay, delta 1 and delta 2, delta 1 and delta 3. So delta 1, for delta 1 and delta 2, we use sine 25 equal to delta 2 prime divided by delta 1 prime. So this is equal to delta 2 prime sine 25. It is 0.423. 423 delta 1 prime. 423 delta 1 prime. And then for cos 25, it is delta 3 prime over delta 1 prime. This is actually equal to delta 3 prime equal to cos 25. It is 0.906. 0.906 delta 1 prime. So this will be the value that we should use. Okay, should use in order to calculate FEM for AB, FEM for BC and FEM for CD. Okay. So for FEM AB equal to FEM BA. Okay, we use 6 EI delta 1 prime divided by L. What is L value? L is 10. Okay, 10 square. So this is equal to negative 100. So we simplify this. We get EI delta 1 prime equal to equal to 100 times 100 divided by 6. 100 divided by 6. We get 1666.667. 1666.667. Okay, 1666.667. EI delta 1 prime. EI delta 1 prime 1666.667. It is negative 100 based on assumption it is negative. It is negative times length. The distance from A to B is 10 meter, 10 square, divided by 6. Okay, it is 1666 divided by 1666.67. Okay, 100 times 100 divided by 6. 1666.67. Okay, so this is the value. Okay, now we apply formula for FEM BC, CB and FEM CD, DC. So FEM BC equal to CB. Okay, and this will be negative 6 EI delta 2 prime over L is 6, yeah? L is 6 square equal to now we calculate 6 divided by 6 square. Okay, it is times with it is negative. Okay, it is 0.423. Okay, it is negative 6 over 6 square EI, okay, times with 0.423 EI, delta 1 prime. So this is equal to, so 6 times 6 square times 0.423 times 1666.667. So it is equal to positive 1117.5 kilonewton meter. Okay, for FEM, CD, DC, it is positive 6 EI delta 3 over 7.46. It is 7.46 square equal to 6 over 7.46 square times with 0.906. 0.906, this is EI delta 1. EI delta 1 prime. And this is equal to 6 divided by 7.46 square times 0.906 times 1666.667. So we get here negative 162.799. So this is kilonewton meter. Okay, so the moment that we will use in the table, is negative 100 for AB and BA. Negative 100 because column angle is positive, FEM is negative. Okay, and then FEM for BC, beam angle is negative, FEM is positive. Okay, this is the value we put in that column. And then FEM DC angle is positive, FEM is negative, so this is negative 162.7 or 0.8. So this is how we find the ratio between each member in frame. So this is actually the most complicated part in frame width side sway analysis, where in this section under 3A, the assumption that we made is actually for one column only, one member only. We assume 100, and we put sign depending on the behavior. And then we have to find the ratio. And because of one inclined column like this, the ratio is not equal. Okay, because delta 1, delta 2, and delta 3 is not equal like what we have done previously. Then we have to find the ratio. The ratio that we find, we should relate with this. Okay, this principle. The angle, the angle we find using trigonometry, using angle, and we find the ratio between delta 1 and delta 2, between delta 1 and delta 3. Then when we apply into the formula FEM for AB, we have FEM for AB, we have FEM for BC, we have FEM for CD. Then we will substitute the value, okay, in terms of EI delta 1 prime. Then we get the moment value. So all this moment we use in the table. So if we have actually set the Excel to calculate FEM, to calculate the end moment from table 1, and in table 1 we have calculate FEM due to loading. So in table 2 we just need to change the FEM only. And this is the most complicated part lah in moment distribution method. And of course after this we have to establish or identify the R prime value, same with R value from table number 1. So the similarity between table 1 and table 2 is the R value. So we will calculate R and R prime value using static equilibrium. The process is same except the moment that we use is different. Okay, the moment from table 1 and the moment from table 2 is different. And once we have be able to determine the R and R prime value, we just need to substitute into the equation, which is actually derived from principle of superposition. Okay, this is about frame with one inclined column. And in the textbook, I actually choose this one to explain because in the textbook there is one example for frame with inclined column, but that one is for two inclined column. Actually, frame with two inclined column is not complicated as this. Okay, you can refer to the textbook. I'm not remember. It is 12 point something. Okay, please relook at that. So it is frame with side sway whenever frame has two inclined column, not one inclined column. And between one inclined column and two inclined column, one inclined column is the most complicated part. So I have covered all this. So please try to watch this and try to understand and then try to do on your own. So inshallah it will help you to answer your assignment later on. Okay, so inshallah I will give you the assignment question as soon as possible. So there will be two questions, one for beam, one for frame. Okay, the frame of course we will be focusing on on maybe one incline column, not sure, maybe one incline column. Okay, and the most important thing, you have to understand and try to apply whatever important terms, important things that I have explained it. Okay, repeat again and again in my video, including the video today. Okay, thank you very much for those who are joining me since at 9. Okay, in this 3-hour session. So if you have any more questions, so you may continue asking in the Teams chat. Okay, so that's all. Thank you very much. Thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.